Hi guys, welcome to this module, Introduction to Active Directory DNS. If Active Directory is the most important component of Microsoft infrastructure, and I'm saying if because I said so, and it is indeed, then DNS is second most important, if not equivalent to Active Directory. And the reason being that there is no benefit of having all these computers and servers and this cloud around us if they cannot talk to each other. That is, without a network. And the building block of network or the way to identify these PCs on a network is IP address. And we humans do not remember IP address very well. What we remember is a name. Hence, the need for name resolution. That is DNS. Let me show you the example of what I mean. So let me open this browser here and let me open the website for you, google.com, your and my favorite website. And I'll go to my command prompt in Mac, it is called as terminal, and I will do ns lookup. I hope you like the tool already because we have been using it so much. And I'm going to look up the IP address of google.com. So essentially what happened here, I did ns lookup and I did google.com. It went to this DNS server, which is actually the IP of my router, because locally my router is configured as my DNS server, and my router actually is asking all these responses from a public DNS server. We are going to talk about public DNS server in a short while, but here is what the end result is, that I got the IP address for google.com. I'm going to copy this address and I'm going to put it here. Voila! I still got google.com. What does it tell you? How easy is it to open google.com because you know the name? Now in place of this name, if I would have asked you to remember this IP address for Google, okay, whenever you want to open google.com, you just have to put 142.250.67.14 in the address bar and you can open google.com. And along with this, you could have remembered the IP address for yahoo.com, amazon.com, for any other website which you like, .com. How easy the world would have been. Do you reckon? It wouldn't have been easy at all. So that's what I'm talking about. That all this computer world is important or is evolved so much because of the network. And the network is useless without DNS because we cannot remember the IP address. Hence, DNS is very important. And no matter what you do as you grow up in your career, whether you become a solution architect or whether you become a product engineer, whether you become some kind of a developer or whatever you want to become as you grow up in your career, DNS is never going to leave you alone as long as you remain in the IT infrastructure space. If you go all together into a application development kind of space, even there DNS is required. And you and I are using the DNS every day when we are browsing internet. So DNS is the most important block, or if I call Active Directory because it's my first love and my favorite subject, then at least it is the second most important or equivalent important topic in IT. So you need to understand it thoroughly so that it can be your friend and not haunt you like enemy throughout your career. And it's not very difficult. Believe me, even if you don't understand it 100% today, over the course of your career, you will understand it. So here is what we are going to cover in this video today. We are going to talk about the type of DNS. So there are two types of DNS. One is the Active Directory DNS, which I showed you before in the last module. And then there is also something which is called as a public DNS. When you open google.com, you're not going to somebody's private Active Directory to look up in the DNS. Or when you open yahoo.com or msn.com, these websites are public domain websites. So their DNS is hosted somewhere else. I'm going to show you. Then we are going to do a Microsoft Active Directory DNS demo, of course. And then I'm going to talk about the root hens and DNS forwarders. Root hens and DNS forwarders are an extension of Active Directory DNS. So let's begin with the public versus private DNS. The Active Directory DNS, which you have running in your environment, is a private DNS server for your network, which means only the resources like PCs, servers, printers, and other LDAP resources access it for name resolution. The PCs which are in your network, the printers which are in your network, the servers which are in your network, the users which are in your network, they access this private DNS for name resolution. And you have a full control on this DNS. You can create whatever records you want to create on it or whatever changes which you want to make on it. As an administrator to Active Directory, you have full access on it. However, there also exists another kind of a DNS, which is public DNS, which exists in cloud, and your zone created there when you buy a domain name from a registrar like GoDaddy or Network Solution. So let me show you. I already showed you the google.com, right? So if I go back here and if I go here and put the name of my website, pledgetechnologies.com, I get a DNS IP. Where did I get this from? I didn't get it from an Active Directory DNS server. I got it from a public DNS server. Or if I put my other domain, which is pledgetechnologies.com.au, again, it's the same IP because the website is hosted at the same place for both the domains. But anyways, these name resolution is not coming from a private DNS server of the Active Directory of pledgetechnologies.com. Got it? Let me show you where it is coming from. So, when we started our businesses, we purchased this domain from GoDaddy, which is a big domain registrar. People go to these companies like domain registrars like GoDaddy, or I would tell you Network Solutions. So you can go to people like these and you can purchase your domain name from them. And every domain name is unique in the world. If I have pledgetechnologies.com, you cannot have it. Once again, a domain name is a reflection of a company identity. And only one person buys it, and when one person or one company buys it, nobody else can buy it. And you can look up your domain name here. Let's see. If you say, okay, I want pledgetechnologies.com, or you know what, let me make it easy. If you say that you want google.com, do you think you will get it? See, google.com is taken. You cannot get it because it's already being purchased. So we purchased our domain from GoDaddy and now we have logged in here, and these are some of the domains which we own. And now I'm trying to go into the DNS. When we purchased the domain from them, they created this DNS for us and it is hosted with them, and these are all the records which we create. Look at this. This is the same IP which is here. 35.213.190.69. So this is the public DNS server. And I believe we discussed the type of DNS records before. So these are the A records which are created here. These are the CNAME records which are created here. Then there would be other kind of records which are created here. SRV, MX. MX is the mail exchanger record. Look at this record here. This tells DNS that my emails are hosted on Office 365. This is a CNAME, or this is a URL which is given to me by Microsoft to put it in my DNS server, so that anybody who is trying to send email to pledgetechnologies.com can see that, okay, their email is hosted with Office 365. Let me send the email to this address, and this ultimately is an IP address. If I go here, okay, let me do this. Copy this and let me put this here. Let me hit enter. What happened? It's an IP address. Ultimately, everything is an IP address. Basically, this MX record, what it says is that any email for pledgetechnologies.com should be sent to this address, and this address resolves to this IP address. That means any emails destined for pledgetechnologies.com will be sent to this IP address. And behind this IP address, there is a whole Exchange server infrastructure which is running there, which is going to absorb that email and then deliver it into our mailboxes and all that stuff. I'm going to talk about Microsoft Exchange Server soon with you in the later weeks of this training. But for now, just believe that this IP address is going to absorb my email and going to send that email to the Exchange servers, and then it will get delivered to me. But all this happened because when I purchased the domain from GoDaddy.com, they gave me this DNS server. And me being the owner of this DNS server, I can create some kind of a DNS record here and I can point them wherever I want them to be. So this is what a public DNS server is. Okay? Alright, so I hope you understand the public DNS. Now we will move on. The next topic is about dissecting Active Directory DNS server. So what we are going to do here is that I'm going to show you more into Active Directory DNS. We briefly touched upon it in the last module, but I want to dig a bit more deep into it, and I want to show you the different kind of things which you can do there. So once again, I'm going to go to my Active Directory server, which is in Azure. And then we will log into it, and then we'll open the DNS console. I will go to my domain controller in Azure, and then I will open the DNS console there, and then we are going to look at all these things. Once again, I am in my PDC server, my primary domain controller, and I'm starting my virtual machine. Remember, I turn it off every night so that it doesn't keep consuming my money. And I only start it when I need to. It's getting started. So my virtual machine has started, and I'm going to copy its IP address because it might have changed its IP address. And I'm going to go to my remote desktop. Where is my remote desktop? I'm going to edit the IP address here before I connect. See, it was 52.147, now it is 13.75 because every time I deallocate my machine, it is going to be reallocated when I start it for the next time, and when it gets reallocated, the IP address changes. Okay, so I'm going to close this. And I'm going to go to run, my favorite place, and dnsmgmt.msc, DNS Management Console. As usual, remember the shortcuts. Microsoft can keep changing the interface, and you will still be able to open everything right there from the run window without worrying about where is the actual shortcut to open it. Alright, so here is what we see. This is Microsoft DNS server. This is the current DNS server in the console. So why it's showing the current server here is because if you had more than one DNS server in this environment, which we will have eventually, then you can right click and connect to another DNS server from here. So you can say that connect to, say there is another server which is ADC, Additional Domain Controller. Once again, the domain controllers can have any name. I just keep the name PDC, ADC to give you a better insight into the primary domain controller concept, which is about the FISMO roles, which we are going to learn in next few modules. But anyways, so I just give these names because I want to give you a better context. But other than that, you can give them any name. In fact, people or the organizations don't give the names like PDC and ADC. They give names based on the location and the data center locations where the domain controllers are placed. All right. So what I was trying to tell you was that if there was another DNS server, we could have put the DNS server name here and we could have clicked OK. And like we are able to see this current server DNS structure here, we could have also seen the structure of that remote DNS server right here. So like I told you that there are two zones. There is a forward lookup zone and there is a reverse lookup zone. And Then under the forward lookup zone, these two zones get created when you install Active Directory. This is the underscore msdcs.rootdomain.com zone, and it has got this record for DC for domain controller. And then sites, these are the sites which we have created in our AD sites and services. And under default site, under TCP, you see here pdc.rootdomain. This is because the domain controller in the default site is PDC. Let me open the Active Directory sites and services, ds site.msc. So this is the default first site name, the default site which got created, and the domain controller inside is the PDC. So hence this DNS structure gets created like this, that under MSTCS you have DC, under that there is site, under that the actual site name, under that TCP, and then under that it says that the Kerberos and the LDAP server. Remember, Active Directory is the LDAP protocol, and the LDAP server means the domain controller is this server, pdc.rootdomain.com. So this is how the structure get created. There is very deep meaning to the reasons why the structure is created like this, and again you are going to see once again PDC global catalog. Where is the global catalog? Again you will go to the sites, and fortunately or unfortunately, basically we just have one server, and that is our global catalog server as well. Also, I'm going to tell you what is global catalog when we go to the FISMO role section, which is later in this training. So just take that as a word for now. Once again, this server is our global catalog server. Again, it shows PDC. But basically what's happening here is that if any client machine or any user come to this DNS and it asks the DNS that, do you know which one is the global catalog server in my site? And the DNS will go, yeah, sure, let me look. Okay, you are in the default site, all right. And under this, okay, yeah, your global catalog server is pdc.rootdomain.com. So it'll be able to quickly tell. And that's how the resolution is happening. So once again, these are some very intricate details which most of the times do not even break. These records are created by default when the Active Directory gets installed, and at most of the times they are not going to get deleted or broken or whatever. And you need to understand these things when you become a senior engineer in Active Directory kind of a things. Every Tom, Dick and Harry is not going to face the issues regarding these DNS records. It is my job to tell you about these things, hence I am telling you about these things. So don't get very terrified that, oh my god, these details are very complicated and how am I going to remember them? 99% of the cases you don't have to remember them. But just understand there are two kind of zones which get created, the underscore MSDCS. The DCS stands for domain controller, Microsoft domain controllers in the root domain, and then you have this whole hierarchy underneath it, and then you get the other the whole Active Directory domain DNS which get created, and under this you will have the DNS record for every PC. Like this Win10 PC exists in our domain, so there is a DNS record for it and it's a hosted record. This file server exists in our domain, so there is a DNS record for it. And the fully qualified name of the file server is fileserver.rootdomain.com. Like if I go to command prompt, this is my primary domain controller, okay, and net config rdr, this is a command, you can also remember it, and I use it to look at the fully qualified name of the server on which I am there at the moment. So the fully qualified name of this server is pdc.rootdomain.com. Similarly, the name of this Windows 10 machine is tempwin10.rootdomain.com. This is like the last name of a person. They have joined the family whose last name is rootdomain.com. So everybody in this family will be called as .rootdomain.com, whatever their first name is. And here if you see, all the records are created with first name because the last name is written here. So this record is ultimately fileserver.rootdomain.com. This is pdc.rootdomain.com. Here, if you go ahead and put full name here, then it will become even bigger. Like sometimes what happens is people try to make, okay, I'm making a DNS record for fileserver.rootdomain.com, and in host record they will go ahead and type let me try to create a new A record. Okay, so while I do that, this is how you create a new A record, and this is how you create any kind of record. So you can right click within this DNS console and you can go ahead and create all kind of records like new A record or AAA record when you have a IPv6 address, which nobody has. So I have never created a host record for IPv6, or I have never had to create a AAA record. CNAME record, which is an alias name, aka the record which points to another record which I showed to you in some of the module in week 2. The MX record, the mail exchanger record, which tells that where to deliver the emails. Once again, you don't create the MX record in most of the situation within your local Active Directory, because your local Active Directory already knows your Exchange server and it can deliver the emails. Okay, so these records are created for external public DNS usually, and this DNS server provides it because it is a DNS server, and Microsoft can also hope that you will use this DNS server as a public DNS server. However, you are never going to do that, but they provide all these functionalities here. So let me show you. I was showing you if I create a record, and I was showing you that we only create a record with the first name. So let's say that you asked me to create a record for a machine which is part of this domain, and its name is server.domain.rootdomain.com. And you see, I just put server here, and the fully qualified domain name automatically becomes server.rootdomain.com because root domain is here. If by mistake I go ahead and make server.rootdomain root domain, what's wrong, domain.com, then what's the fully qualified domain name? server.rootdomain.com.rootdomain.com. So that will be wrong. So we don't do it like that, and we just put the first name here. That's why you here only see the first name, and then you go ahead and put whatever IP it's going to be. So because this is your DNS record, so you can do whatever you want to. You can create any kind of a record, but in most of the Active Directory cases, the DNS record will automatically get registered here, because the machine, when it joins the domain, it is pointing to your DNS server and the information get updated here. But sometimes you are creating some new kind of a service, or you are creating an internal website. In those cases, you will have to come here and create a DNS record. So that's why I'm showing this to you. Okay, so you can just say this, and this DNS record got created automatically, right? And let me do a NS lookup, and I do server dot root domain.com, and look, I got the response .78. You created the DNS record here, I got the response. That's how DNS works. If I'll go ahead and delete it, then I'll not get the response. Okay, let me try this. Before I try it, I will do flush DNS, because once the DNS is cached into my PC, it might respond with that cached information. So it's always a good practice, in fact a troubleshooting step, to do a ipconfig flush DNS before you try to resolve the address again. So that was server.rootdomain.com. It can't find it because I deleted it. Similarly, you can create a CNAME record. So this is a CNAME record, and CNAME record is a record which points to another record. So let's say that we want to create a website, and we create it on our file server. On our file server, we install IIS, and then we create a website on top of that, and we go ahead and we create a record here, website .rootdomain.com, and what is going to be the IP address of this? Where is the website running? On the file server. So either I can create a record, and I can also give it the IP address of 10.0.0.8, or instead what I can do is that I can just point it to my file server record. Now what happened? Whenever somebody is going to resolve website.rootdomain.com, he will get redirected to this address, and then this address will finally resolve into this IP address. So I will do website.rootdomain.com. What happened there? It resolved the address to first fileserver.rootdomain.com because that's the CNAME here, and then it also told me the IP address is this. So that's what is a CNAME record. These are the kind of records which you usually use. Now, once again, the structure here is created for the reasons of complicated Active Directory, and I would not go into the details of these records, but ultimately these records are created as per the sites, and these records are provided here to tell you which server is responsible for the role of global catalog, for the role of Kerberos server, and for the role of LDAP server in this site. And in our case, we only have one domain controller, so the only server which is responsible is PTC. So that's how DNS resolve all these information. All right. Now, so what did we look at? In our training, we looked at the forward lookup zones and the reverse lookup zones. I showed you A record, I showed you CNAME record, I showed you PTR record, and I showed you NS lookup. So I already showed you NS lookup, and PTR record, I've already told you that it gets created under the reverse lookup section. It hasn't got created because it usually doesn't. But if I want to really do this, and while creating, let's say I will go ahead and create a new record, a record, and I will just name it anything, ignore it please, and I make it 10.0.0.56, and I put a check here, create associated PTR record, and then I say add host. So this got added here, and I assume now, okay, still it didn't get created. It might get created later. Okay, it's created now. So this is the PTR record, and now what's going to happen is that if I go ahead and search for 10.0.0.56, it's going to tell me it is temp.rootdomain.com. So the reverse lookup actually resolved from IP to name. Like I said, that it's usually not of any use. There are only very few applications which needs to do that. So that's what a PTR record is. Now we are going to the next interesting topic, which is about root hints and forwarder. Your private DNS server is not God. What I mean by saying that is that your DNS server only have the required information to resolve your local network resources, like the PCs which are in your network, the resources, the printers, the servers which are in your network. You already saw this. Your domain DNS record is only consisting of the machines which are in your domain. So where do they get the resolution done for the public sites or any external resource like google.com or amazon.com? Because let me show you here. Of course, there is no zone for amazon.com here, but let me go ahead and do amazon.com. It still got the information. These are the IP address for amazon.com. Is the information for yahoo.com. Where is it getting this information from? So, what is uses for this DNS information is something which is called as DNS root hints or DNS forwarders or conditional forwarder. Let me go through the definition first. DNS root hints are the default pointers to resolve the addresses which your local DNS server is not aware of. So when you install the Microsoft DNS server, by default, this tab is created, and I didn't put this information here. This information got put in by default by Microsoft when it installed it. And all these are root servers in DNS, the God DNS public servers, which have the information about every domain in this whole wide world. And what's happening is that whatever DNS information we are not able to resolve using this DNS, my DNS server forward that information to one of these servers, and then it asks those servers, it gets the information from there, and then it delivers to the client. Okay? So what happened when you did Amazon.com? We still went to our DNS server, which is this server, and it said, you know, I don't know it, and it went to the God DNS servers, which are provided in these root hints, and then it got the information from there, and then it responded. It did it really quickly because computers are really, really fast. But that's what happened. So those are root hints. DNS forwarders. These are configurable IPs which you can put in your DNS server for your nearest public DNS server so that it can resolve any information which it is not aware from there. Okay. Now, I'm currently in Sydney, Australia. I have no clues where these servers are. And Microsoft did not care about my physical location. These information is definitely pre-packed into a Windows server from somewhere, and when it installs the DNS, it just pre-populates this information. It has no regard for my local placement in what part of the world I am. And if you remember, during the DNS troubleshooting, or rather during the slow internet troubleshooting, I told you that when you put ping 4.2.2.2, which is IP of one of these root servers actually, this time which you are getting, this time which you are taking to get response from here, it defines what is the speed of your internet is going to be. Because if this time is going to be really, really high, then that means that is the amount of time which it is taking to exchange the information for every website which you are going to browse. First you have to go to DNS and get the IP address from there, the name resolution done from there. If that name resolution alone take 400 milliseconds here, then can you browse fast? No, you cannot. Your DNS itself, every name resolution is taking so much of time for you. Now, this is a problem. So what we do is that we usually don't rely on these servers. Otherwise, our internet can become very slow. So what we do, we go ahead and put a forwarder here. And this forwarder is something which we find from our local internet provider. Like my ISP would have given me a forwarder or would have given me an IP address to resolve. Let me show you. I'll give you a real example here. So I'll go to my router, which is 192.168.1.1, and I'll log in here. See, this is the public IP which has been given to me, and this is the DNS server which my ISP, Internet Service Provider, has given to me. Let me go ahead and ping this, and as well as 4.2.2. So on my computer, let me clear this screen first, and then I will ping 4.2.2.2, and what is the time? 100 millisecond, 102 millisecond, 150 millisecond, 101 millisecond, alright? This is millisecond, this is not even second, but still it counts when you are browsing. Okay, and now let me try to ping the DNS server which my ISP gave. I have really no clues where this server is located. So I'm going to put my ISP IP address here. Look at the response time, 24 millisecond, 11 millisecond, 10 millisecond, 11 millisecond, 69, 71, 11, 11. So basically, here I was getting an average of 100 millisecond, and here I'm getting an average of 10 milliseconds. It is 1/10 of what you were getting. So what do you think I should put as a DNS forwarder? 4.2.2? Should I rely on the root hints which are given here? I don't even know the physical location where they are. Or instead I should just ask my ISP, what is your DNS server? And I can just put that IP address here. That makes more sense to me, because that's going to affect my speed. So DNS forwarders, unlike root hints, are configurable forwarding IP addresses. And when you have a DNS forwarder, then the request don't go to root hint. All the request goes to DNS forwarder. So if I have an Active Directory here in Australia, and I want to my people to be able to browse internet, because my all machines will only point to the primary domain controller for my DNS. They will not point to public IP addresses from my ISP. So my machines have to rely on this DNS server to resolve google.com for them. And for them to be able to resolve it, I will take the IP from my ISP DNS server and I will put it here so that they can ask my DNS server. My DNS server can quickly go to my ISP DNS server, get the response from there and give it to my client, and everybody can browse fast internet. So those are DNS forwarders. The next thing which we want to look at is the conditional forwarding. So they are exactly same as forwarder, but they are conditional. Conditional generally in the name of a domain. So what happens is that we know that for all domain queries which end with rootdomain.com, this DNS server is sufficient to provide the information. Then we set up a forwarder here to say that for anything apart from rootdomain.com, which is google.com, yahoo.com, apple.com, amazon.com, you go to this DNS server, my forwarder DNS server, and get the information from there. But for some reason, and those reasons are usually trusted domains or neighboring domains or those kind of domains, you say that if you have a DNS request regarding the resource of company B.com domain, then you go to 10.0.0.56, or maybe it's a different IP range, so it is 172.16.8.9. This could be the domain controller in this other domain. Remember the trusted domains which we talk about? So you purchased a company, your neighboring company. You want to resolve the DNS information from that company. That company DNS information is also not the private DNS zone of that other neighboring company is not published in internet. An Amazon DNS server or a public DNS server is not going to resolve their private record. Who can resolve their private record? Their domain controller. So you need to create a conditional record. So what you are going to say, for every information except rootdomain.com, you can go to the public forwarder, which you configured here, right? So for every DNS request except rootdomain.com, go here. However, if your request is about another private domain, which is my neighboring company, which I recently purchased, companyb.com, then go to their domain controller, whose IP is this. Alright? So this is a conditional forwarding. That means don't go for all DNS record to companyb.com, only for the DNS record which ends in companyb.com as a domain name. So server.companyb.com, go to company B. Website.companyb.com, go to company B. And by company B, their domain controller. Go here to resolve it. So this is what is called as conditional DNS forwarding. Alright. Okay guys, so that's the end of this module. And here is what we covered in this module. We spoke about what are the types of DNS server. I gave you a demo of Microsoft Active Directory DNS server, and I also told you a lot about root ends and DNS forwarders and conditional forwarders. So I hope you got a better hang of the DNS server or the Active Directory DNS server. You also understood that there is a bigger DNS server out there in the world which is not as restricted as our private DNS server. Okay, so that's what this one was about. For your action item, I hope you already have your primary domain controller created. So run through the DNS Active Directory console. Maybe you can create another forward lookup zone and reverse lookup zone. So here is how you create it. You say so you go under forward lookup zone and you say new zone, and you can pretty much create any zone here. You have option to say create yahoo.com. You can create yahoo.com or any other DNS zone, whatever you want to, like nobody is going to stop you But this is your private DNS server. If you want to create a yahoo.com here, you can do this, and you can set up any kind of record here, mail.yahoo.com. If you want to, then you can create it, and you can point it to any IP address, whatever you like. It will stop the resolution of all the client in your domain. If they're trying to go to yahoo.com, they will not be able to go anywhere, because your DNS server will start resolving yahoo.com, and you have incorrect IPs for yahoo.com. So you will not be able to browse the website. But yeah, you can try to create a couple of new zones just to get a hang of it. Go through various DNS record, create a record with the name my PC, point it to your existing client, and try to ping the name from the server. So like I created a DNS record, so just go ahead and create a DNS record here, and then do a NS lookup like I created this temp and website. So get a hang of that. Create a CNAME record, call areas, and point it to my PC A record. So this is what I did here, website, and I pointed it to file server. You can do that. Use NS lookup to query my PC A record and alias CNAME record and confirm all is working fine. So I already use NS lookup. You can do that. Read more about forwarders and conditional forwarders. I think, yeah, just go through these things. Once again, try to absorb as much as information possible, and learn more and more about DNS, because it's not going to leave you anytime soon. The more you know about it, the better it is for you. And believe me, it might sound a little too much to you as of now, but eventually this will become your second nature. In next couple of years, if you keep working and growing in the industry, DNS will become your second nature, and it better become your second nature, because if it does not, then it's going to haunt you a lot. So learn more about it. Play with the NS lookup, create different kind of a records, different IP address, and see how it works out. And just a reminder that if you query a certain record, say website.rootdomain.com, and then you go ahead and change the IP address there, and then you query it again, then it might very well just give you the old IP address. In those cases, please remember to do ipconfig /flush DNS, because once the PC cache a record, for a quite bit amount of time, it will keep responding to you with the same IP address. All right, thank you, and I hope you enjoyed this module. I will see you in the next one soon.